Let's go ahead and look at a problem where you're given two different sets of points that go through a line, and our job is to determine whether those two lines will be parallel, perpendicular, or neither. And to do that, since we're given 2 points on a line, we're going to go ahead and use the slope formula. So, just a reminder, if the lines have the same slope, then they're going to be parallel because they're never going to intersect since they're following the same pattern. If they have their slopes as the opposite reciprocals, meaning they have different signs and the reciprocal of their slopes, then they're going to be perpendicular. So that means they're going to intersect at some point, and when they intersect, they're going to form a 90-degree angle. So just a reminder here, if we're ever given 2 points, the way we would find the slope would be to use one of these different ways that we have, um, which is using this formula that we have here, which is essentially the change in y by subtracting the two y coordinates over the change in x, which is subtracting the two x coordinates, since slope is the rate of change of your line. So I'm going to go ahead and identify here the different lines that I have. So I'll call this line here uh, that contains point A and B, line 1, and the line that contains point C and D as line 2. So my goal here is to find the slope of those two lines. And then I'm going to compare the slopes and I'm going to make the conclusion on whether they're parallel, perpendicular, or neither. So for line number 1, and for both lines, I'm going to go ahead and label my coordinates that I have here. And I just go in order. My first point will be my x sub 1 and y sub 1, and my second point will be my x sub 2 and my y sub 2. So according to my formula here, I'm going to go ahead and find the change in the y's, which is just subtracting those two y coordinates. We're going to apply the same strategies for the change in x, which is subtracting the two x coordinates. And since we started with that second point, when we do the change in x, we also have to start with the second point. Okay. The rest is just simple calculations. We end up with that. And since we're comparing slopes, we should probably reduce our slopes to the simplest form. So the greatest common factor here would be 6. So if we do that, we end up with 1 over 2. Negative 1 over 2. You can put the negative in the numerator, denominator, or right at the center of the fraction. And we're going to go ahead and perform the same formula for this second line. Careful here, the original formula has a minus and the number after the minus is negative, so we still need to include the negative sign on that number. Same thing happened right here with the negative 6. Then since we have a double negative, it turns into addition, so I'm going to go ahead and clean this up a little bit. And no, I don't know where the 9 came from. I think I was just thinking about the answer. So let me go ahead and change it. That was 6. There we go. So we just do our calculations here. We get 18, 9 at the bottom. We simplify it. This fraction is going to become a whole number. But because we're comparing the slopes, I'm going to go ahead and just leave it as a fraction. So I'm going to go ahead and put it as 2 over 1. Or, like I said, it turns into a whole number. So we can leave it as 2 as well. Okay, so the next piece here is to compare the slopes. Our comparison will allow us to make our conclusion. So we notice here that we have slopes with opposite signs. One of them has a negative slope, the other one has a positive slope, and the slopes are the reciprocals of each other. So that means that the lines will be perpendicular. I'm going to go ahead and express why they're perpendicular, which is what I just said right now. The slopes have opposite signs, or I can just briefly say that the slopes are opposite reciprocals. That indicates that it has opposite signs and that they're reciprocals of each other.